In working with electrical circuits, it will be necessary to obtain different values of DC voltage or DC current. In a simple circuit, the voltage source is called a dry cell or battery. A battery is actually two or more dry cells joined together. The dry cell develops its voltage through converting chemical energy into electrical energy that can be applied to a circuit. The voltage across one cell is approximately 1.5 volts. When dry cells are connected in series aiding, the total voltage will be increased. In a series aiding connection, the cells are wired together so that the positive terminal on one cell is connected to the negative terminal of the next cell. With two cells connected, the voltage is approximately 3 volts. By adding more cells in series aiding, the voltage will be increased. If the cells are connected in opposition, positive to positive and negative to negative, their voltages will cancel. The total voltage will then be 0. If 4 cells are connected in series aiding, they will furnish 6 volts. However, if one of these 4 cells is incorrectly connected, series opposition, it not only fails to contribute its 1.5 volts, it cancels the amount of its voltage. The total voltage in this 4-cell combination is 3 volts. Cells can also be connected in parallel. Like terminals are joined together, positive to positive, negative to negative. This schematic shows 3 cells connected in parallel. The 3 negative terminals are connected on one side and the 3 positive terminals are connected on the other. The combined voltage of cells connected in parallel is no greater than the voltage of any single cell, approximately 1.5 volts. Each cell connected in parallel contributes to the workload. Therefore, the life of the cells is extended. Now, let's take a look at how a dry cell is constructed. Its outside container is a zinc metal can. A high carbon rod is suspended in the center of the can. The can is then filled with a chemical paste consisting mostly of zinc chloride. The zinc and carbon react with the chemicals in the paste, forcing electrons from the center rod to the outer case. As a result, the zinc becomes negatively charged and the carbon rod is left with a positive charge. The chemical dry cell eventually wears out. When the chemical energy is depleted, the dry cell must be replaced. Remember, a battery is a number of dry cells connected together. This schematic symbol shows a series of cell symbols in a row without any wires connected in between. There are other types of batteries that can be recharged when the chemical reaction is depleted. They're called wet cells. An example of a wet cell is an automobile battery. Most automotive batteries are made up of 6 cells connected in series aiding, supplying 12 volts. When wet cells are discharged, they can be recharged by reversing the current flow through them. A discharged wet cell battery must be recharged by another source of voltage, such as a battery charger. Every time a wet cell battery becomes discharged and is recharged, it has gone through one cycle. After a number of cycles, a wet cell battery can no longer be recharged. It's considered worn out and it must be replaced. Please, always make sure to dispose of batteries properly.